3 says to calculate the x coordinates of the points of intersection of the curves in part 2. So if we go back to part 2, we can see that there were 2 points of intersection. So we're looking for 2 solutions to when 2 cos a third x is equal to sine a third x. And we're looking in the range 0 to 6 pi. And we're expecting to get 2 answers. So how do we solve this equation? Well, if we divide by cos a third x, we will get sine a third x over cos a third x. And one of the things that we've not used for this entire paper, we've not done much trig at all, is the fact that sine of something divided by cos of the same thing gives us tan of that angle. So we've got tan a third x equals 4. If we inverse tan, if we do the inverse tan, we'll get that a third of x is the inverse tan of 2. Making sure that we're in radians. And that gives me 1.1, sorry, that's a third x, 1.11 radians. But for the tan graph, because we know we're expecting 2 values, in order to get the second value for tan, it repeats every 180 degrees. So if we add on, or that's pi radians, so if we add on pi to that, 4.25 radians. But that's for a third of x. So if we then times both things by 3, both of those answers by 3, we're going to get, actually, when we do it correctly to 3 significant figures, we only get 3.32 radians. So be careful of rounding errors here. Or 12.75 radians. Which, that second one seems quite big, but if you think about it, we're going up all the way up to 6 pi and 6 threes at 18. So that's still within the range of values that we're expecting. So 3.32 or 12 point, it would be 12.7 to 3 significant figures if you look at the rounding.